Have you ever wondered why some places have tall mountains while others have wide plains or deep valleys? Why do volcanoes erupt? Why do earthquakes happen? And how did these amazing landforms come into existence? The answer lies in the incredible forces that have been shaping our planet for billions of years. In today's video, we'll begin an exciting journey to understand landforms and their evolution, how Earth's surface is created, changed, and continuously reshaped. By the end of this lesson, you'll see our planet in a completely new way. Landforms are specific physical features on the Earth's surface, such as mountains, valleys, and plains, that evolve through the continuous interplay of internal, tectonic, volcanic forces and external agents, water, wind, ice, waves. Over time, these landscapes sequentially transition through three distinct stages of development: youth, maturity, and old age. Understanding landforms and their development requires examining how different environmental forces carve and shape the Earth's surface. Running water, fluvial landforms. Landforms created by running water, also known as fluvial landforms, are shaped by the processes of erosion, transportation, and deposition of sediments by rivers and streams. These landforms are dynamic, continuously evolving as water flows through various landscapes. Youth stage, or erosional landforms. Rivers primarily erode vertically. This rapid downcutting forms deep, steep-sided features, V-shaped valleys. Formation. When a river cuts downwards into its bed through vertical erosion, it creates a steep-sided, narrow valley that resembles a V-shape. Example: the Grand Canyon carved by the Colorado River, the Yarlung Tsangpo Gorge in the Himalayas, and the upper valleys of the River Liffey in Ireland. Waterfalls and rapids. Formation. Waterfalls form where layers of hard and soft rock meet. The soft rock erodes faster than the hard rock, creating a drop. Rapids are sections of a river with a steep gradient that cause turbulent water flow. Examples: Angel Falls, Venezuela; Victoria Falls, Zimbabwe; Niagara Falls, USA and Canada; Jog Falls, India. Gorges and canyons. Formation. Over time, if a river continues to cut downwards, it can create deep, narrow valleys known as gorges or canyons. Examples: Fish River Canyon, Namibia; Grand Canyon, USA; Gandikota Canyon, India; Copper Canyon, Mexico. Maturity stage, or depositional landforms. Vertical erosion lessens, and the river begins to widen its valley. Floodplains. Formation. These are flat areas of land adjacent to a river, formed mainly by the deposition of sediments during periodic floods. When the river overflows, it deposits layers of alluvium, silt, sand, and clay, on the floodplain. Example: the Indo-Gangetic Plain, Mississippi River Alluvial Plain. Levees. Formation. Natural levees are raised banks formed along the sides of a river channel due to the deposition of coarser sediments during floods. Over time, these levees can become quite pronounced. Example: levees along the Yellow River, China. Deltas. Formation. When a river enters a standing body of water, like a sea or lake, it loses velocity and deposits sediments, forming a delta. Deltas are typically triangular or fan-shaped. Example: Ganges-Brahmaputra Delta in India and Bangladesh, the world's largest; the Mississippi River Delta in the United States; and the Nile River Delta in Egypt. Alluvial fans. Formation. These form when a river spreads out and deposits sediments as it flows out of a mountainous region onto a flatter plain. The sediments fan out, creating a cone or fan shape. Example: Death Valley in California, the Kosi River Megafan in Nepal and India, the Teesta River Fan in West Bengal. Old age stage. the gradient becomes incredibly gentle, forming broad, flat plains. The river sluggishly deposits sediment, creating braided channels, oxbow lakes, and expansive deltas at the mouth. Meanders, formation. In the middle and lower courses of a river, lateral erosion and deposition create sinuous curves known as meanders. Erosion occurs on the outer banks, creating river cliffs, while deposition happens on the inner banks, creating point bars. Example: the meanders of the Mississippi River and the Ganga River. Oxbow lakes. Formation. These crescent-shaped lakes form from abandoned meanders. When a river cuts through a narrow neck of a meander during a flood, it creates a new, shorter channel, leaving the old meander loop as an oxbow lake. Examples: Lake Chicot, Arkansas, USA. Reelfoot Lake, Tennessee, USA. Kanwar Lake, Bihar, India. Groundwater. Karst topography. In regions with soluble rocks, like limestone or dolomite, underground water sculpts the landscape through chemical solution and precipitation. Karst refers to any topography or landform that forms over soluble rocks. The classic karst landforms, which include enclosed depressions, sinking streams, and caves, are primarily generated by surface and subsurface waters dissolving rocks. Mechanical erosion plays a secondary role. Surface erosional features. Sinkholes, dolines. Funnel-shaped or circular depressions that form when surface rock dissolves or underground caverns collapse. Swallow holes, honers. Openings where surface streams or rainwater flow directly down into the underground rock system. Uvalas. Large compound valleys or depressions formed when multiple adjacent sinkholes merge. Poliers. Very large, flat-bottomed valleys enclosed by cliffs featuring internal drainage. Limestone pavements. Exposed rocky flat surfaces split into raised blocks called clints, separated by deep grooves called grikes. Karst towers. Hills. Steep, isolated residual limestone hills left standing as the surrounding landscape erodes. Subsurface erosional features. Caves and caverns. Large underground cavities formed when acidic water moves through fractures and dissolves the bedrock. Karst windows. Openings or gaps where a portion of an underground cave roof collapses, exposing the subterranean stream below. Disappearing and blind valleys. Surface stream valleys that abruptly end where water sinks straight underground into the rock network. Major karst. Depositional features. Stalactites. Icicle-like mineral deposits that hang down from the roof of a cave, formed by water dripping and leaving calcite behind. Stalagmites. Upward-growing mounds or pillars that rise from the cave floor directly beneath stalactites from dripping water. Columns. Pillars. Solid vertical structures created when a growing stalactite and a matching stalagmite meet and join together. Flowstones. Smooth, sheet-like layers of calcium carbonate formed by thin sheets of water flowing steadily over cave walls or floors. Drapes. Curtains. Thin, wavy sheets of hanging calcite deposits that form when water drips along a tilted crack or linear fissure in the ceiling. Travertine and tufa. Crystalline or porous calcium carbonate deposits left behind by mineral-rich springs and streams outside or at the mouths of caves. Glaciers. Glacial landforms. Glaciers shape the landscape in two main ways, through erosion and deposition. Basically, a glacier picks up materials like rocks and sediments in one place, then later sets them down in a different place. Erosional glacial landforms. Cirque. A deep, bowl-shaped or armchair-like depression found at the head of a glacial valley where snow and ice first accumulate. Arête, a sharp, knife-edge mountain ridge that separates two adjacent glacial valleys or cirques. Horn, a sharp, pyramid-like mountain peak formed when three or more cirques erode a single mountain. U-shaped valley, a steep-sided, flat-bottomed valley carved out as a slow-moving glacier widens and deepens a former river valley. Fjord, a long, deep, U-shaped coastal valley flooded by the sea. Striations, scratches and grooves gouged into bedrock by rocks frozen into the bottom of a moving glacier. Depositional glacial landforms. Moraine, long ridges or mounds of unsorted rock debris and sediment, till, deposited along the sides, middle, or front of a glacier. Drumlin, an elongated oval-shaped hill of glacial till pointing in the direction the ice flowed. Esker, a long, winding ridge of sand and gravel left behind by meltwater streams flowing beneath melting ice. Kettle Lake, a small depression formed when a buried block of ice melts, leaving a hollow that fills with water. Erratic, a large, isolated boulder transported and dropped far away from its original bedrock source. That brings us to the end of Part 2 of Landforms and their evolution, Physical Geography. In Part 3, we'll explore how wind, waves, and ocean currents shape and transform the Earth's surface, creating fascinating landforms over time. Join us in Part 3 to continue the journey.